Hi everybody, today we're going to be doing the Basic Education Annual National Assessment of 2015 for Grade 7 Mathematics. It's a 2-hour test and it counts out of 100. So I will put in the link to the test in the description below, and also in the description below I will place time markers for each question, so you can just click on the time next to the question and it will take you straight to that question. Okay, so question 1 is multiple choice, and we can start with 1.1, and they ask us what is the lowest common multiple of 5 and 7. Now if we quickly check, let's just write out the common multiples of 5 and 7 here. So we've got 5, 10, 15, 20, 25, 30 and 35, and if I take 7, we'll go 7, 14, 21, 28, 35, and we can see that the first common multiple, meaning the lowest one between both of them, will be 35, so the answer is B. Alright, then if we look at 1.2, they tell us in 6x plus 2 the variable is. Right, so what is a variable? A variable in this scenario would be C, it would be x, because x is the only thing in this equation here that can change in its number, meaning it's variable. It can be anything. X can be anything. 6 can't be anything other than 6, and 2 can't be anything other than 2. So the answer is C. Then in 1.3, they ask us 32 written as a product of its prime factors is. Alright, so I'm just quickly going to write it out on this left side here. So if I have 32, and I'm quickly going to use the ladder method to just write it as a product of its prime factors. Remember, we start with the smallest one, 2, so 32 divided by 2 gives me 16. 16 again divided by 2 gives me 8. 8 divided by 2 again gives me 4. 4 divided by 2 gives me 2. And I can again divide by 2, and that will give me 1. So here is my prime factors, and we can see we've got 1, 2, 3, 4, 5, 2. So the 32 written as the product of its prime factor will be 2 times 2 times 2 times 2 times 2, which is C. Right, then in 1.4 they ask us what percentage is 1,200 out of 5,000. Alright, and I'm going to do it here on the right hand side. Let's just do it here at the bottom. So basically, if we want to get the percentage of something from another number, we can say, well, what is the percentage of 1,200 of 5,000? So we're going to write 1,200 on top of 5,000. And remember, when we want to take something to a percentage, we want to take the bottom, meaning the denominator, to 100. So let's just quickly try and cancel here. We can see that these 2 zeros will cancel with the 2 zeros there. Let's just try and simplify our fraction here, and then we get 12 over 50. And remember, we want our denominator to be 100. So what can we do? We can multiply top and bottom with 2 to get our denominator to be 100. Then we will have 24 over 100. And now we know that that will simply be 24%. So in this case, our answer is A. Okay, if we now proceed to 1.5, it tells us what is the value of 3 minus k over 2 if k is equal to 4. So all that we're going to do here is, and I'll solve it here on the right hand side, all we're going to do is simply substitute in k's value, and they tell us that k is 4. So we've got 3 minus k, which in this case is 4, divided by 2, and that would simply be 3 minus 4 over 2 is just equal to 2. So our answer is 3 minus 2 is 1. So the answer here will be B. In 1.6 they ask us a quadrilateral in which all 4 sides are equal is called a what? Right, we know it's not a rectangle, because in a rectangle 2 of the sides are equal and the other 2 are equal as well. It's not a parallelogram, it's in fact a rhombus. So a rhombus is a shape with 4 sides, so it is a quadrilateral, and we've got that all 4 of the sides are equal to one another. Then a set of points with a definite starting point and no definite end point is called a ray. So we can think about like a ray of sunshine, because we know a line segment, it will have a starting and end point. So to a straight line and a perpendicular line. So we've got a ray. In 1.8, they ask us in the figure above, or rather in this figure, WX, that line there, and ZY are what? So because we've got these two little arrows here, we know that these two are parallel to one another. So if they were perpendicular to one another, then they would have made a 90-degree angle, which we can see they don't do there. But they are indeed parallel to one another. So the answer is B, meaning that the angle between these two will remain, or the angle of these two lines are equal, meaning they will never intersect one another. Alright, then in 1.9, they ask us the perimeter of a regular pentagon with one side equal to 5 centimeters is. So firstly, the perimeter is simply the addition of the lengths of all the sides of a shape. So we're just going to add the length of each side and add them together. So we know that a pentagon has 5 sides and all 5 sides are equal to one another. So if the one side is 5 centimeters, that means the perimeter would just be 5 times 5, which gives me 25. So the answer is A. In 1.10, they ask us the relationship between x and y is what? Right, so we can see that when x is equal to 1, y will be equal to 4. So we know immediately that the first, well, A in this case would not work, because if we had 5 times x, that would already not work, because 5 times 1 will give me 1, and we can see that that's not the case here. If we look at B, we can see that 3 times x, that would also not work, because 3 times 1 in this case will give me 3, which is not 4, so that one wouldn't work. C tells me y is equal to x plus 4, so when x is 1, if we take 1 plus 4, it will give me 5, but that's not y's value here. The value is 4. Let's check the last one, x plus 3. So when x is 1, 1 plus 3 will give me 4. So it works. Let's just check it for another one. When x is 2 plus 3, then yes, it gives me 5, which is y. And you will see that it works for these last two cases as well. So my answer is D. In question 2.1, they ask us to calculate without using a calculator. We need to show the calculation steps when needed. So in 2.1.1, we've got 1,643,884 plus 262,206. So the most important thing when we're adding numbers, especially where we have numbers which are not equal in the number of digits they have, so we can see the first number goes up into the 1 millions, or up until the millions, and the second number only goes up until the hundred thousands. So it's important to write down our numbers below one another properly. So we've got 1,643,884, and below that we've got, I'm just writing it down in reverse to make sure we get everything beneath one another, meaning we've got the ones below the ones, the tens below the tens, the hundreds below the hundreds, and so forth. Alright, so in any case, if we've done that correctly, we can start adding up, and we've got 6 plus 4 will give me 10, so the 1 will carry over. 1 plus 8 will give me 9, 8 plus 2 will give me 10 again, and we've got the 1 which carries over. 1 plus 3 gives me 4, plus 2 gives me 6, then 4 plus 6 gives me 10 again. We've got the 1 carrying over. 1 plus 6 is 7, plus 2 is 9, and 1 plus nothing is 1. So our answer is 1,906,090. In 2.1.2, we have got 6,517 divided by 31. Right, so we can see that 31 can't go into 6. So we can put a 0 there, you don't have to, it doesn't really mean anything, it's just a placeholder if you wanted to. And then we can say 31 goes into 65 2 times. And 2 times 31 will give me 62. So if I take 65 minus 62, it will give me 3. And we take down the next value, which is the 1. 31 goes into 31 once. And 1 times 31 will give me 31. So I'm going to deduct that, and it will give me 0. Then we bring down the 7. 31 can't go into 7, so it goes into 7 0 times. And 0 times 31 will give me 0, so we're going to minus the 0 and we take the 7 down. There's no other number to take down, so the 7 will be my remainder. So 6,517 divided by 31 is 210 with a remainder of 7. If we now move over to 2.1.3, we've got our multiplication sum here of 315 multiplied by 236. So 6 times 5 will give me 30. So I can put my 0 there and I can take the 3 over. 6 times 1 gives me 6, plus the 3 gives me 9. And then 6 times 3 will give me 18. Right, now we can cross this 3 out there, and we can say now we're going to move over to the 3, but remember it's a 30, so we have to put our 0 placeholder there. Then 3 times 5 is 15, so I'll put my 5 there, and I'm going to carry over the 1. 3 times 1 is 3, plus the 1 there is 4, and then 3 times 3 gives me 9. Right, then lastly we're going to move over to the 2, but remember it's actually 200, so we need to put our 2 0 placeholders in. 2 times 5 gives me 10, so I'm going to put the 0 there, and we're going to put the 1 there, so we can just leave that one. 2 times 1 is 2, plus 1 is 3, and then 2 times 3 is 6. Alright, now we're just going to add everything together, and we get in the first, for our 1s we get 0. 9 plus 5 gives me 14. Carry the 1 over, so it's 1 plus 8 is 9, plus 4 is 13. And again we've got the 1 that carries over, so it's 1 plus 1 is 2, plus 9 is 11, plus 3 is 14. And last one that carries over, so 1 plus 6 gives me 7, and that is our final answer. So 315 multiplied by 236 gives me 74,340. In 2.1.4 we are given 2 cubed, so 2 to the power of 3 times 1 to the power of 4. So we know that 2 cubed can be written as, and I'm just going to write it here at the top, is the same as saying 2 times 2 times 2. And this is simply 2 times 2 is 4, times another 2 will be 8. So we've got 2 to the power of 3 is the same as saying 8. And 1 to the power of 4 is simply the same as saying 1 times 1 times 1 times 1, which we know will just remain 1. So we've got 8 times 1, which will remain 8. And then we've got the square root of 144. So we know that the answer for the square root of 144 will be, when we multiply these two numbers with one another, they should give us 144. And we know that that is 12, because when we multiply 12 with 12, it will give me 144. So we've got 12 plus 6 squared is simply 36, so it's 6 times 6. And 12 plus 36 will give me 48. In 2.1.6 we've got 3 over 5 multiplied with 7 over 6. So when we are multiplying with fractions, we know it's quite simple. So we simply multiply the numerators with one another and the denominators with one another. So we know that would be top times top, bottom times bottom. So in this case we would have 3 times 7 gives me 21, and 5 times 6 gives me 30 at the bottom. We know that our fraction is not yet in its simplest form, so let's check for a number that can divide into the top and the bottom without having a remainder, and we can see we can use 3. So 21 divided by 3 will give me 7, and 30 divided by 3 will give me 10. So now our fraction is in its most simplest form. If we move over to 2.1.7, we've got 0.012 divided by 4. Now they want to trick us with the fact that we're dividing by a decimal number which is smaller than 1. But it shouldn't be difficult. We simply approach it in the very same way. So we know that 4 can't go into 0, so that's 0. And just remember, when you're working with your decimals, it's very important to keep the same place where your decimal mark was and to include all your zeros. So 4 again can't go into 0, so we're going to add our 0 there. 4 can't go into 1, so we've got another 0 there, and then we can actually bring the 12 down, and we can see that 4 goes into 12 3 times, and that's our answer. So 0.012 divided by 4 is equal to 0.003. Right, and then for 2.1.8 we've got 100 minus 12 divided by, in brackets, 8 plus 4. Now it's very important to remember your BODMAS here, so the order of our operations. So we know in BODMAS that we're going to start with our brackets. So let's do that, and we can see that I'm going to do this in multiple steps. So let's leave the 100, and then we're going to say minus 12 divide by, and this bracket simply becomes 8 plus 4 gives me 12. Right, now if we look at our BODMAS, we can see what are we left with here. We are left with a minus, and we are left with a division. So we can see that divide here is before subtraction, which is last. So we are basically going to do our division first, and if we wanted to, we could even put this in brackets for ourselves just to make it easier. So we've got 100 minus 12 divided by 12 is simply 1. So 100 minus 1 will be 99. In question 2.2, we've got, or rather they're asking us to write 1.6 as an improper fraction in its simplest form. Right, so basically what we can say here is we know when we want to take a decimal number to a fraction, we're always going to either put it over 10 or 100 or 1,000 or something like that. So we can basically see that 1.6 written as an improper fraction will simply be equal to 16 over 10. And I'm just going to describe that here at the top quickly. So we know that if we've got 16, it's the same as saying 16.0, and that is over 10, and we know that 16.0 over 10 is simply the same as saying 16.0 divided by 10. And you know from your earlier maths that when we divide by 10, we know that our comma simply shifts to the left by 1, because we've got 1 0 there. So that's the same as saying 1.6. So hence I'm saying 1.6 is the same as saying 16 over 10, but we know that our fraction here is not in its simplest form yet. So what can divide in the top and the bottom? We can take 2. So we've got 16 divided by 2 is 8, and 10 divided by 2 is 5. So 1.6 as an improper fraction in its simplest form is 8 over 5. Right, now in 2.3 they're asking us a group of 25 grade 7 learners watched a soccer match. The ratio of the number of boys to the number of girls was 2 to 3. How many boys were there? Right, now I'm going to explain this by using a sort of a little graph. So the first thing you can do when you look at ratios is we can see they've got 2 to 3. So they are basically looking at 5 learners, if I can say it like that. So for every 5 learners, they're saying that 2 are boys, and they are saying that 3 are girls. Alright, so when we are looking at the entire class, we want to take this sample of 5 learners and apply it to the entire class, which is 25. So how do we take 5 and make it 25? We have to multiply it by 5, which would give us 25, which is the entire class. Likewise, we have to multiply our ratios by 5. So if we multiply this by 5 and that by 5, we would see that 2 times 5 gives me 10 boys, and 3 times 5 gives me 15 girls. So we can see that in the class of 25 children, 10 are boys and 15 are girls, but they only asked me what the number of boys are, so we can say that this is 10 boys. In 2.4, they ask us to calculate 10% of 15 Rand. Right, so the first thing we want to do here is we don't want to be working in different types of numbers. We don't want to be working in percentage and whole numbers, or numbers rather. So let's convert this 10% to a fraction, and because that's the simplest thing to do with a percentage, and then also convert the 15 Rand to a fraction. So remember, whenever you see of, you can imagine it as being a multiplication problem. So like I said, we want to write our 10% as a fraction, and we know that percentage is always over 100. So this is 10% is the same as saying 10 over 100. Remember, I said of, we can see is a multiplication, and then 15 Rand and 0 cents, going to put it like that, is the same as saying 15 over 1. And now it's easy, because remember we said when we multiply with fractions, it's simply the top times the top and the bottom times the bottom. But before I times here, I can see that this fraction on the left, the 10 over 100, I can simplify a bit. And I can divide the top and the bottom by 10, or I can simply cancel a 0 on each side. So I've got 1 over 10 multiplied by 15, 0 over 1. So 1 times 15 in this case would simply give me 15, or 15, 0, let's just put the comma there, and 10 times 1 gives me 10. And remember what we said in one of our earlier problems. We said anything over 10 is the same as just saying divide by 10, and we can then shift our comma to the left by 1 space. So 15, 0 divided by 10 is the same as saying 1, 5. And remember, we're working in Rand, so calculate 10% of 15 Rand is simply 1 Rand and 50 cent. 1,5 Rand. The 0 there at the end doesn't really matter, but since we're working in cents, let's put it in. Alright, and then in 2.5 we've got John travelled by car at an average speed of 80 kilometers per hour for 4.5 hours. Calculate how far he travelled. And again, I don't want to be working in different types of numbers here. So let's take the 4.5. Let's just make it an improper fraction here. So we're going to say 4 times 2 gives me 8, plus 1 gives me 9. So 4.5 is the same as saying 9 over 2. And how can we determine how far he travels? So we can say if he travels 80 kilometers per hour, that means in 1 hour he will go 80 kilometers. So if we want to find out how far he traveled in the 4.5 hours, we're simply going to multiply it with 80. So I'm going to say multiply by 80, sorry, that's an ugly 8, 80 over 1. Right, and now we can say 9 times 80. Again, you can simplify this if you wanted to by cross simplifying and say it's 9 over 1 multiplied by 40 over 1. But let's keep it as it is. So 9 times 8 is simply 72. So remember, we can just add the 0 later. We can see it as 9 times 8, and that gives me 72. But remember your 0 because it was 80. So 720 divided by 2. And if we quickly do this on the side, we've got 720 divided by 2. 2 goes into 7 3 times. 3 times 2 is 6. So 7 minus 6 is 1. We bring down the 2. And 2 goes into 12 6 times. 6 times 2 is 12. So that's 0. We bring down the 0. 2 can't go into 0, so we add it there. And our answer is 720 divided by 2 is 360. And remember, this is kilometers, because they asked us how many kilometers does he travel. So John traveled at 80 kilometers per hour for 4.5 hours. Calculate how far he traveled. He traveled 360 kilometers. In question 3.1.1, they ask us to fill in the missing numbers in the following number sequence. Now, they give us 1, 4, 9, blank, 25, and blank again. So there's actually more than one way in which we can determine what the missing numbers are, but I'm only going to show you the one way in which I believe they wanted you to see it in. And problem 3.1.2 actually alludes to that. So we can see in 3.1.2 they ask us, are the numbers in the above number sequence prime numbers, square numbers, or cubic numbers? So we know it will be one of those three. So we can see that it will definitely not be prime numbers, because we know that 4 is not a prime number, nor is 25, and 1 is actually not a prime number either. So let's look at the next possibility, which is square numbers. So let's think of this as our term 1. So I'm going to sort of just quickly write here at the top term 1, term 2, term 3, term 4, and term 5, and it actually goes up until term 6. So we've got term 1, which is basically our first number. So 1 squared will remain 1. If we look at the second term, so if we had 2 squared, that would give me 4. So that's 2 squared. 3 squared will give me 9. And 5 squared will give me 25. So thus far it works for everybody. So we know that 4 squared will be 16. So that's my first missing number. And then 6 squared will be 36. So we know that they are indeed square numbers. So we can go ahead and write that down here for 3.1.2. Let's just make double certain that it's not cubic numbers. So 1 cubed would give me 1. So it does work for the first case. But 2 cubed would be 8. So we already know that it doesn't work there. And we've got that 3 cubed would give me 27, which is definitely not 9. So it is in fact square numbers. In 3.2, they give us a bunch of octagons, meaning we've got 8 sides here. So they say, study the following diagram pattern of regular octagons and then complete the table below. So we can see that when we've simply got one octagon, we have got 8 sides. We know that when we have got 2 octagons, we've got 15 sides, and we can go and count them if we wanted to, but basically we can see that it's not just 2 times 8, which would give me 16, because the 2 octagons share a side. That's why it's only 15. And then when we look at our 3 octagons here, we can see that there are 2 sides which are shared between the 3 octagons. So basically this side is shared between these 2 octagons, and this side is shared between these 2. So we know that basically if we look at the patterns that we have so far, they sort of repeat themselves, and we can see that if we had 2, the number of sides would be 2 times 8 minus 1, or if it was 3, it would be 3 times 8 minus 2. So 3 times 8 is 24, minus 2 is 22. So we know if we have 4, it would be 4 times 8, but then we have to minus the number of sides that share, and we know that there would be 3 sides that share if we added another octagon here. So I can't really draw it very nicely, but imagine this being an octagon. Then we can see if we've got 4 octagons, there would be 1, 2, 3 sides sharing. So it would be 4 times 8 minus 3, and that would simply be 29. So we've got 4 times 8, which would be 32, minus 3, which gives me 29. Now they want us to write a general term for the number of sides. So it doesn't matter how many polygons we have, imagine it being n. Now look at the formula we had here. The number of polygons that we had was this 4 here. So we could say it would always be n, which is the number of polygons we have, times by 8, because we know that they have 8 sides, and we can minus. So we're always going to minus, the number of sides we minus is 1 less than the polygons we have. So when we had 1, we minused 0. So it was 1 times 8 minus 0, which is 8. When it was 2, it was 2 times 8 minus 1. So the minus will always be 1 less than the amount of polygons. So if we have n polygons, we're going to minus n minus 1. And this would be our general term there. So we could say 8n, which is the same as just saying 8 times n, minus n minus 1. In 3.3, they tell us use the given rule to fill in the missing values in the flow diagram below. Right, so they give us P on the left-hand side and T on the right-hand side, and they give us our rule in the middle here. So the first thing I want you to realize is let's look at BODMAS to analyze our rule, and we've got 2 multiplied by P minus 3, but we know we're looking at BODMAS. Our multiplication is before subtraction, so I'm going to put brackets there for myself just to make it easier. So we've got 2 times P, and we're going to do that first and then minus 3. Let's make sure that works for our rule. So if P is 7, that would be 2 times 7, which is 14, minus 3 gives me 11. So it does work. Right, so for 3.3.1, I'm going to say T is equal, let's just quickly put this here, 3.3.1. So T is equal to 2 times, and P in this case is 11, minus 3. So we've got 11 times 2 gives me 22 minus 3, and that will give me 19. So 3.3.1 is equal to 19. I'm going to come back to 3.3.2. I'm first going to do 3.3.3, which is also on this side because it works the same as the one we just did. So if we were to look at 3.3.3, we've got that P is equal to 20, and they ask us what would T be. So we've got 2 times 20 minus 3. So we know 2 times 20 gives me 40, minus 3, that will give me 37. Right, so we've got for 3.3.3 T to be 37. Right, now in 3.3.2, they give us the value for T, but they don't give us the value for P. So we're sort of going to be working in reverse. So I'm going to say, what I mean by that is, since they gave us T, we know 21 is equal to 2 times P minus 3. So since we now want to calculate P, we want to get it on its own, this side of the equal sign. So to do that, we're going to work in reverse, and rather than saying minus 3 on this side, we're going to say plus 3 on that side. So we sort of take the 3 over, and it becomes 21 plus 3 gives me 24 is equal to 2 times P. And since we're working in reverse, we want to get rid of this 2. So when it's 2 times P, we're going to say divide by 2. So when we divide by 2 on both sides, I'm going to do that, divide by 2 and divide by 2. 2 times P divided by 2, so the 2's will cancel, and I'm simply left with P. then we get that 24 divided by 2 is 12. So P is equal to 12. And if you want to make sure, whenever you get a sort of a spider diagram like this and you have to work in reverse, whenever you get an answer, you can go and check yourself. So let's quickly do that. I'm going to do that completely here on the side. So imagine we didn't have T here. We know it should be 21, but let's see if we get there. So if we had T is equal to 2 times P, which is 12, minus 3, this would be 2 times 12 is 24, minus 3, and that is 21. Okay, so we know we're correct. So we know that P should be 12. In 3.4, they say calculate the value of C cubed plus 12 if C is equal to 3. So this is simply where we have to substitute in the variable. So they tell us C is equal to 3, so we can go ahead and put that 3 in there. So if we've got C cubed, and we know that C is 3, this would become 3 cubed, or 3 to the power of 3, plus 12. And 3 to the power of 3, we know, is simply the same as saying 3 times 3 times 3, plus 12. And we know that 3 times 3 is 9, times 3 is 27, plus 12, this would give me 39. In 3.5.1, they ask us to solve the equations by inspection only. So that means we just need to look at the problem and know what the answer is. So they say k divided by 3 is equal to 9. So don't get confused by the variable that they use here. It doesn't matter what they use. We simply think about it as what number divided by 3 will give me 9. And we know that 27 divided by 3 is equal to 9. So k would be equal to 27. So we know if we had 27 over 3, it would be 9. Hence k is 27. In 3.5.2, we've got y minus 17 is equal to 13. So what minus 17 will give me 13? And we know that that is 30. So y is equal to 30. And we can test that by saying 30 minus 17, and we know that that will give me 13. Right, now in 3.6.1, they ask us to write an algebraic expression for the following. X increased by 5. So if we've got a number x and it increases by 5, we can simply say x plus 5. In 3.6.2, they ask us to write a number sentence for the following. 2 times a certain number p decreased by 8 is equal to 12. So let's just start at the beginning. 2 times a certain number, so 2 times a certain number p, decreased by 8, so we know we're going to minus or subtract 8, is equal to 12. In 3.7, the given graph illustrates the number of hot dogs sold on different school days during 1 week. Right, so we've got the number of hot dogs sold here on our vertical or y-axis, and the days of the school week on our horizontal or x-axis. So in 3.7.1, they ask us how many hot dogs were sold on Thursday. So let's check. On Thursday, we just follow the line up until we reach our graph, which is there. We trace it back to the number of hot dogs sold, and we can see it's 50. Alright, so on Thursday, we sold 50 hot dogs. On which days did the sales remain constant? So let's see. We can see from Monday to Tuesday it decreased from 40 to 20. On Tuesday to Wednesday it remained the same because we've got a flat line there, and we can see it was 20 on Tuesday and it remained 20 on Wednesday. So on which days did the sales remain constant? It's Tuesday and Wednesday. Sorry for the horrible handwriting. In 3.7.3, they ask us to calculate the difference between the number of hot dogs sold on Monday and on Thursday. So the first thing I want you to recognize here is the word difference. So we know that whenever we see difference, we know it's going to be a subtraction problem. So let's look. On Thursday, they sold how many hot dogs? We know they sold 50. So we're going to say 50 minus or subtracted by the number of hot dogs sold on Monday, which is 40. So 50 minus 40 is 10. So the difference between the numbers sold on Monday and Thursday is 10 hot dogs. 4.1, they ask us to study the triangles marked A, B, C, and D. And they ask us to complete the table below by filling in either A, B, C, or D. Right, so they ask us for an equilateral triangle. Now we know in an equilateral triangle all the sides are equal to one another, so we know it will be C, because these little lines on each of the sides indicate that they are equal to one another, so this will be C. A right-angled triangle, that will have to be B, and we know it by this little square that's in the corner, so we know that that angle is the right angle, and meaning that B is a right-angled triangle. Then an obtuse angled triangle, we know this will be D, because this angle here is an obtuse angle. So an obtuse angle is simply an angle between 180 and 90 degrees, so meaning it's larger than 90 degrees but smaller than 180 degrees. Then in 4.2 they ask us to study the diagram below and answer the questions that follow. So in 4.2.1 they ask us what kind of angle is angle C. So we can see that angle C is basically an angle that's less than 90 degrees, meaning it is an acute angle. Then 4.2.2, what kind of angle is angle B? But take note in which triangle you're working in. So they're telling us in triangle A, B, C, so in this large triangle here, what kind of angle is B? And here we can see that this is an obtuse angle, since it is larger than 90 degrees but smaller than 180 degrees. Right, then what kind of angle is angle D within the triangle BDC? And again we can see this little box here indicating it's a right angle. Then in 4.2.4, name a pair of perpendicular line segments. So we know that when line segments are perpendicular, they are 90 degrees to one another. So there are multiple perpendicular line segments, either BD and DC or BD and AD. So I'm just going to say BD and AD. In 4.3 we continue with geometry, circle geometry in this case, and they ask us, tease the center of the circle, name the parts of the circle that are listed. Okay, so in 4.3.1 they ask us PQ is called what? So we can see that since PQ starts at one edge of the circle and continues to another edge of the circle and passes through the center T, this is a diameter. So remember, a diameter has to be a line that starts on one edge of the circle, continues to another edge of the circle, a straight line, and it has to go through the center. And then TM is basically the radius, since it starts at the center of the circle T and goes to the edge of the circle. So it doesn't matter where the line ends on the circle, as long as it starts at the center and it ends anywhere on the circle, it will be called a radius. Then 4.3.3, PS is called, so we can see here P and S. So we've got a line that starts on the edge of the circle and continues, a straight line that continues to another edge of the circle, but it does not pass through the center. Then it is called a chord. So just remember, any line that touches two edges of the circle but does not go through the center is called a chord. Right, then if we look at 4.4, So when looking at figure A, we can see that this will be a parallelogram because we've got our two opposite angles being parallel to one another. Likewise for these two sides, rather, they are parallel to one another. So yes, figure A will be a parallelogram. If we look at figure B, we can see that we've got two angles which are equal in length and the other two which are equal in length as well. So this is a quadrilateral where we've got two sides being equal in length and the other two sides being equal in length, meaning that this would be a kite. And we can see it sort of looks like a kite which is currently upside down. And then if we look at figure C, we can firstly see that this is an unequal shape. So let's count the number of sides, and that would, or the number of angles rather, which would give us what type of unequal shape this is. So if we count them, it's 1, 2, 3, 4, 5, 6, and 7. So we know that it's an unequal hexagon. Unequal hexagon. Right, and then if we look at figure D, we can see that the sides seem to be equal, and there are 1, 2, 3, 4, 5. Wait, 1, 2, 3, 4, 5 angles, so it is a pentagon. In question 5.1, they ask us, or they tell us rather, in an equilateral triangle PQR, PQ is equal to 23 millimeters, and they ask us to complete the following. In 5.1.1, they tell us that QR is equal to PR is equal to what? Well, we know that in an equilateral triangle, all of my sides are equal in length, meaning that QR and PR will be equal to 23 millimeters. Likewise, since the sides are all equal in length, we know that all three angles will be equal to one another as well. And we also know that in a triangle, sorry, I know it's not really to scale here, but since all three sides are the same, we've got that all of our angles must be the same as well. And we know that the inside angles of a triangle, when we add them together, they should give us 180 degrees. So we could basically say that each angle will be equal to 180 divided by 3, which is 60 degrees. So angle P and angle Q and angle R will be equal to 60 degrees. In 5.2, they ask us to study the diagram below and then answer the questions that follow. So in 5.2.1, they ask us, what is the length of DF? So that side there. And we can see by these little two lines here and those two there, we can see that the length of ED is equal to DF, meaning that DF would simply be 4 centimeters. And then if angle E, this one here, is 40 degrees like they've shown us in the figure, what is the size of F, this angle here? Now, since we know that EF is just a straight line between the two of them, and we know that ED is the same in length as DF, we know that angle F will have to be 40 degrees as well. In question 6.1, they ask us to study the pairs of diagrams below and complete the statements by filling in A or B or C or D in the spaces provided. So in 6.1.1, they ask us the two shapes in what are congruent. So basically, when shapes are congruent, it means that they are completely alike. They are similar in size, and all of their sides have the same length, and all of their angles are the same size as well. So I would say this is D, because we can see that these two shapes are completely alike. the one is just lying opposite to the other, but the lengths of all of the sides are the same, and the angles are all the same as well in both of them. So we can see in all three the other figures provided, A, B, and C, we can see not one of them are the shapes even the same size, so it has to be D. In 6.1.2, they ask us the two shapes in what are similar. So when shapes are similar, it means their angles are completely alike, but the shapes are not the same size. So in this case, I would say that it's A, because we can see that both these triangles, the angles of them are completely the same. The sides or the lengths of the sides are just not the same. So that angle there is the same as that angle there. This angle here is exactly the same as that angle there. Likewise, this angle here and here. So the angles are the same, but the sizes are different. If we take a look at B, we can see that angle there seems to be smaller than that angle there. So these ones are not similar. Likewise here, this angle to me seems to be smaller than that one there. In 6.2, they ask us write down whether each pair of triangles given below is congruent, similar, or neither. So if we take a look at 6.2.1, they ask us triangles in pair 1 are what? So we can see firstly that by the lines indicated, this line here is exactly the same in length as this line here. This line here is the same in length as that line there. And they share a common line here, so obviously it will be the same for both triangles. So if we look at this triangle, all the sides are equal in length, meaning that the angles will also be equal in length. So since the sides and the angles are equal in length, we know that these pairs are congruent. So the triangles in pair 2, basically this triangle here and this triangle here, we can see that they look exactly the same in shape, but they are different sizes. But if we look at this angle here, it seems to be the exact same as this angle here. Likewise, this angle seems to be the exact same as this angle here, and that angle is the same as this one. So the angles are equal to one another in both triangles, but they are different in size. The length basically of the sides are different. So this, the triangles in pair 2 would be similar. Point 1, they ask us to calculate the perimeter of a rectangle if the length is 11 centimeters and the breadth is 5 centimeters. So we know that in a rectangle we would have that our length would be the same for our opposite sides here, and our breadth in this case, which is 5 centimeters, would also be the same for our opposite sides here. So we know that the perimeter of any shape is simply the sum of all of the lengths of the sides. So in this case, we would, if we wanted to, we could have marked our rectangle and say that's A, corner B, C, and D, which would mean that my perimeter would simply be, like I said, the sum of all of the sides' lengths. So it would be AB plus BC plus CD plus DA, or AD, it doesn't matter. And now we can simply go and substitute in. So we know that AB is 11 centimeters, plus I will add the units back at the end. BC is 5, plus CD is 11, plus another 5. So we have, basically you could have said 11 times 2 plus 5 times 2. So we've got 22 plus 10, so that gives us 32 centimeters. In question 7.2, they ask us to write down the formula for the surface area of a cube. So in a cube, we know that it's basically just, you can see it as a box where all of the sides are equal in length. So we know in the first case that the surface area for a square is simply length times breadth. But in this case, the length and the breadth is exactly the same. So you could see it as length squared, or length times length. But let's quickly just calculate how many surface areas we have for a cube. And if you have trouble seeing this, just take a little box and look at it. So we know that obviously the dotted lines here are inside the box, which we can't see from the front. So the first one would be the angle that we're looking, if we looked at the box straight ahead. So that I'm going to call it angle, or rather surface 1. And then if we were to look from the left hand side, that would be surface 2. If we're looking at the top, that would be surface 3. If we were looking from the back, that would be surface 4. So between those ones, between these sides here, if we were looking at from the right hand side, that would be side 5, or surface area 5. And then if we looked at it from the bottom, that would be surface number 6. So we know that we've basically got 6 surface areas which are all the same, and since all of the lengths are the same, we can say it's length times breadth, or L times B if I were not to do it in cursive. So like I said, because the length and the breadth are the same, we can say it's length squared, and since there are 6 of them, I can say the surface area is equal to 6 times the length squared. In 7.3, they tell us in a rectangular prism, as we can see here below, the length is 5 centimeters, the breadth is 3 centimeters, and the height is 10 centimeters. And they ask us to calculate the volume. So what I'm going to do is, let's just indicate the lengths of all of our sides in the diagram that we can see here. So they tell us the length, basically that side there, and that there, and there, they will be 5 centimeters. Then they tell us the breadth, so these angles like these ones here, they are 3 centimeters. Then the height, so these sides here like that and that, that and that, they are 10 centimeters. Right, but we didn't even need to draw it in, because we know that volume is equal to my length times my breadth times my height. So we've got that this would be 5 times 3 times 10 centimeters, and I will put in the units at the end. So we've got 5 times 3 gives me 15, times 10 gives me 150. But remember, since we have 5 centimeters times 3 centimeters times 10 centimeters, my units will be centimeters cubed. Right, so if we had the area, since the area is only length times breadth, then we have centimeters times centimeters, and it would be centimeters squared. But since we've got 3 units of centimeters multiplied by one another, it's centimeters cubed. So in question 8.1, they tell us a mother is twice as old as her daughter. How old is the daughter if the mother is 64 years old? So this is quite simple. Obviously the daughter would just be half of 64. So we could say 64 divided by 2, which gives me 32. Or if we wanted to write this as a mathematical term, we could say, imagine the daughter's age being x. So we would have 2 times x is equal to 64. And if we divide both sides by 2 to get x alone, the 2 and 2 will cancel there. 64 divided by 2 is equal to 32. Right, and in 8.2 they tell us the product of 2 prime numbers is 10. What is the difference between the 2 prime numbers? Alright, so let's first look at the key words in our problem here. So firstly, the product, meaning multiplication of 2 prime numbers is 10, and then they ask us what is the difference, so when we subtract them basically. Right, so the product of two prime numbers is 10, and the first ones we can think of immediately would be 2 and 5, because when we take 2 multiplied by 5 it would give me 10. And then they ask us what is the difference between these two numbers. So again, it's going to be a subtraction problem, so I'm simply going to say 5 minus 2 is equal to 3, and that would be our final answer.